This lesson, I'm going to go over how to multiply radicals together. So you should be able to multiply radicals and then simplify it if you need to. And by the end of the video, you should be able to explain the process for multiplying radicals using the academic vocabulary, multiply, product, distributive property, and square root. So example 1, multiply, and then we need to simplify at the very end if we can. So square root of 6 times the square root of 2. So there's no numbers in front of these radicals, so this is sort of the easiest case. All we're going to do is we're going to multiply the 6 and the 2 together. So 6 times 2, and that gets you 12. And then can we reduce 12? So, well, 12 is 3 times 4. Well, let me show it this way. 4 times 3. So 4 is your perfect square, and then 3 is the number that's not a perfect square. So this gets you square root of 4 times 3. And then if you'll recall, this is square root of 4 times square root of 3. So notice square root of 4 is 2, and square root of 3 is 3. So this is 2 square root of 3. Example 2, so multiply, and then again, simplify if you can. So to put these under one square root, I'm going to do 3x times 11y. Remember, parentheses mean multiply. So I'll just multiply the two numbers together. 3 times 11 is 33. And x times y, those are not like terms. So I'm just going to write this as x times y. And this is as simplified as this radical is going to get. There's no way to simplify x times y, or 33. So what happens when you have a number in front of the radical? So I have 3 square root of 10 times the square root of 5. Well, if there's not a number in front, then you can always assume, or you could always write, that there's a 1 in front. So if you don't see a number in front of the radical, it's understood that there's a 1 there. So when we multiply radicals, we're going to multiply the numbers out front. So I'm going to do 3 times 1. So 3 times 1. And then we'll multiply the numbers underneath the radical. So then I'll do the square root of 10 times 5. So 3 times 1 is 3, 10 times 5 is 50. But can we reduce 50? And hopefully you could see that you can reduce that to 25 times 2. So this would be 3 times the square root of 25 times 2. And then 25 is your perfect square, so I'm going to move it outside the radical. So it's going to be 3 times 5 square root of 2. 3 times 5 is 15, square root of 2. So that's your answer for that one. Example 4. Again, this is multiplying, but it's showing you that they could show it with parentheses instead of the dot or the star. So we have 2 square root of 21 times 10 square root of 6. So again, I'm just going to multiply the two numbers out front together. So I'm going to do 2 times 10, and then I'm going to put my square root, and then I'll multiply 21, let's not do that, 21 and 6. So 21 times 6 is 126. And then we're going to just simplify this. So 2 times 10 gets you 20, and then the square root of 126. 126 could be reduced. This would be 9 times 14, I believe. Yeah. So 9 times 14 gets you 126. So then I'm going to rewrite this as 20 times the square root of 9 times 14. 9 is a perfect square, so we could take that out of the radical. Square root of 9 is 3, so this would be 20 times 3 square root of 14. So 20 times 3 gets you 60. And then square root of 14 is going to stay square root of 14. So you can't reduce that any further. So this is 60 times the square root of 14. Example 5, so this one's a little bit more challenging, but we can handle it. So we have 2 square root of 6x times 5 square root of 12x to the 6th. So again, numbers out front we're going to multiply together. So 2 times 5. And then what's inside gets multiplied together. So 6x. So here's my inside. 6x times 12x to the 6th. Now, 2 times 5 gets you 10. I'm going to do 6 times 12. So 6 times 12 is 72. And then x to the first times x to the sixth. When I multiply, I'm just going to show it. X to the first times x to the sixth. Remember, properties of exponents that we went over in the last video is if I'm multiplying, I have the same base, I'm going to add the exponents. Now, we could go on and we could say that this is 10 times the square root of 72, x to the 7. We could do that. But remember, we want x to be even, the power on x to be even. So if I wanted this to be an even power on x, I would have to reduce this by 1 to get me x to the 6th, which I have right here. So, so I'm just going to leave it this way because I already have my even exponent on x, and then I have an exponent of 1 on this x. So this is actually kind of fine the way it is. The next thing I want to do is reduce 72. So 72 is 36 times 2. So this is 10 times the square root of 36 times 2 times x to the first times x to the sixth. Remember, we didn't combine those because it was already in the form that we wanted. Our two x's were. Now I'm just going to simplify what's inside. So the square root of 36, that's 6. So this would be 10 times 6. Can't simplify the 2. Can't simplify x to the first because that's not divisible by 2. X to the sixth, that sixth power is divisible by 2. So this is 6 divided by 2 is 3. And then what's left is the 2x inside. So 10 times 6 gets you 60, x cubed times the square root of 2x. So that's the answer for this one. So 60 x cubed square root of 2x. Example 6, so this one requires the distributive property. So again, I'm just going to show the ones on the outside of my square root. So I have 1 square root of 3 times 5. So I'm just going to use the distributive property. So remember, numbers on the outside get multiplied together. So I'm going to do 1 times 5. 5 is not inside the square root. It's outside. There's no square root around the 5. So I'm going to do 1 times 5. So that's outside. And notice there's no square root for that 3 to be multiplied by, so I'm just going to say square root of 3. And then we'll distribute it to the second term. So I'll say plus 1 times negative 1. So 1 times negative 1. So the number's outside, and then the number's inside. So 3 times 2 gets you 6. And then I'm just going to simplify this. 1 times 5 is 5, square root of 3. 1 times negative 1 is negative 1, so this will be negative 1, square root of 6. And you can't combine those are not like terms because your radicals don't match, so you're just going to leave this as your answer. So example 7, I have square root of 7 times the square root of 2 minus the square root of 7. So again, I'm just going to show the ones out front just so that we remember that there's a 1 there. So I'll do 1 times 1. So if I do 1 times 1, when I distribute the first time here, then I'll do square root of 7 times 2. 7 times 2 is 14. Plus 1 times negative 1 times the square root of 7 times 7. And I'm just going to show this multiplication so you can see it. So 1 times 1 gets you 1. So this is 1 square root of 14. 1 times negative 1 gets you negative 1. 7 times 7 is 49. But we know the square root of 49 is 7. So we could just write this as the square root of 14 minus 7. So that would be our answer there. So the last part is multiplying by a conjugate. So this idea of a conjugate, what is a conjugate? In technical terms, it is a binomial formed by negating the second term of another binomial. What does that even mean? So simply put, the conjugate, if I have a binomial, so if I have, for example, a minus b, the conjugate you're going to get by just changing the sign that's in between. So instead of having a minus b, a conjugate would be a plus b. So I'm just changing the sign to the opposite sign of what you see. the conjugate of 2 minus square root of 5. So again, you're just changing the sign that's in between. So that would be 2 plus square root of 5. For the next two, I want you to give those a try. Make sure you include them in your notes. So give those a try. So the interesting thing that we're looking at is what happens when you multiply conjugates together and we have square roots in them. So a very useful result comes out of it. So when you multiply binomials, remember there was the FOIL method is what you use to multiply these things together. There's also the box method. So I'll do this one using FOIL, and then I'll use the next one using the box method. So with this first example, if I use FOIL, first the outer terms get multiplied. So I'm going to do 3 times 3. Then the outer, so 3 times negative square root of 10. And again, I didn't write the ones, but you could write them there. So this would be plus 3 times negative square root of 10. Then the inner, so plus 1 square root of 10 times 3. And then last. So this would be plus 1 square root of 10 times negative 1 square root of 10. So we're just going to simplify this thing out that we have. So 3 times 3, we know that that's 9. 3 times negative square root of 10, well, the 3 is on the outside, but I didn't show it, but here's your 1. So this would be negative 3, so 3 times negative 1, square root of 10. And then here again, 1 times 3 is 3, so that's plus 3, and then I have my square root of 10. And then the last part, positive 1 times negative 1 on the outside is negative 1. And then square root of 10 times square root of 10, so it's square root of 10 times 10. So what I want you to see is notice this middle term, minus 3 square root of 10 and plus 3 square root of 10. Those are the same term. One is negative, the other is positive. So they cancel each other out. They go away. They're 0. So this is very nice because it gets you down to these two terms, 9 minus 1 square root of 100. And we could just say 9 minus the square root of 100 if you really wanted to. But what's the square root of 100? We know that. It's 10. So this is 9 minus 10, which is negative 1. So the nice result is that it becomes, there's no square roots left when you multiply a square root by its conjugate. So example 9, FOIL would be the preferred method, but I'm going to use the box method for this one, just so you can see how it works with the box method. But again, you could use FOIL. So the box method, remember, you're going to draw yourself a box. There's 2 terms in each. So I have square root of 3 minus the square root of 11. And if you could make this change, just this next one should say plus. And square root of 3 plus square root of 11. And again, you could show the ones there if you truly want to. So we'll take care of multiplying this first box together. So 1 times 1 is 1. Square root of 3 times 3 is square root of 9. Just multiplying the 3's together. Then we'll do the box below it. So this box, this will be 1 times 1. So this 1 times that 1 is 1. And then 3 times 11 is the square root of 33. Now this box, I'm going to do negative 1 square root of 11 times 1 square root of 3. So negative 1 times 1 is negative 1. 11 times 3 is 33. So square root of 33. And the last box, positive 1 times negative 1 is negative 1. 11 times 11 is 121, so square root of 121. And then we could write this out. So this would be I'm not going to show the ones. So this would be square root of 9 minus the square root of 33 plus the square root of 33 minus square root of 121. And hopefully you see, well, these middle 2 terms, just like before, they cancel out. Those are 0. Negative square root of 33 plus square root of 33 is 0. So square root of 9, we know the square root of 9 is 3. And the square root of 121, that's 11. So 3 minus 11 gets you -8. So notice in either case, your middle terms canceled out. So you get -8 for your answer for this one. So this is always going to happen when you multiply a square root by its conjugate. You'll have those middle terms cancel. So please make sure that you submit this notes that you took to week 1 multiplying radicals asynchronous. So this is going to get turned in under that week 1 assignment.